Alright, so we were working on doing embedded crypto on a microcontroller. Today, the two encryption schemes that we're working with are AES and Chacha20. So we're going to go over AES first. First thing we did was download code from GitHub, and then through that code we had to select the microcontroller that we were using, which is the MSP430G2553 right here. It'll include the proper libraries. And then the next thing that we had to do was select the encryption. We decided to use Tiny AES. And then we also, in order to do some of the benchmarks for timing and power, we needed to include some UART code that we had from our previous assignments. So this is all the same, just imported over. We did have to add a UART.h file in order for the main file to utilize the UART functionality. The next thing we had to do was modify some of the timing values. So the UART code that we have utilizes a timer, which happened to conflict with the timer that was used in the experiment time library. And so we just had to import or change the experiment timer from T0 to T1, as well as we found that when we were doing some of our initial testing, some of the seconds or the time was inaccurate because it would roll over in milliseconds. So we converted milliseconds to seconds and print that out. Next, we can go through the main code. We just initialized the board in AES. And then the third way that we measured time was by using an oscilloscope and just monitoring a pin, which will be set to high before encryption and then set to low after encryption. Again, we then start the provided timer, and then we go ahead and encrypt. We run for 8,192 cycles. This is to get to the 1 megabit of data because each will be encrypting one block each time, which is 128 bits. We also check that the encryption is correct. If it is not, we will retry the attempt, so we have to decrement I. Finally, we will get, we will set P2 to out, and then we will also get the elapsed time. We will convert that integer to a string, and we will print that out. And then that is the end of the code. So now you'll be looking at the debug way that we did it. So we set a breakpoint, and then we ran the code, and the variable shows up in the top right of your screen of the amount of seconds that have passed. Now you'll be looking at the COM port way. So this is the actual printout of the time. And then now you'll be looking at the oscilloscope timing. This was used with the setting the pins high or low. Finally, the last calculation we had to do was power. So you'll be looking at that power calculation. And so you can see that the expected and the calculated values are pretty close together, as well as now we'll be looking at the setup that we used for the power calculations, which was taking a resistor and putting it between the 3-volt rail and the chip to calculate how much current was drawn over that resistor. All right, so next up we have Chacha20. This was also code downloaded from GitHub, and then we just pulled over the timing and UART files that we used and modified from AES. And then we did pretty much some of the same things in main, board init, the encryption initialization. Same thing with the pins, timers, same amount of data being encrypted, same call to encryption, same, I guess, encryption verification, and then again, getting all the times and printing them out. So now you'll be seeing the debug, how it was done with debug, again, setting breakpoint. And now you'll be seeing the result in the COM port. And then now you'll be seeing the oscilloscope timing and the associated picture of how we hooked up the oscilloscope to the board. And now you'll be seeing the power calculations that we did also with the oscilloscope. All right, and that is it.